Hey guys, today we're going to learn LCM and GCF part 3. So in this video we are going to learn GCF particularly, and in our previous videos we learned LCM. So now in this video we're going to learn GCF. So before we continue, don't forget to subscribe, like, and share. GCF basically stands for greatest common factor. It can also be called highest common factor. And we are going to go through that concept in this video. Okay, so now GCF of 3 and 6. So I'm just going to tell this little method or strategy you can use right now, because throughout this video I will teach you two other good methods that are efficient and time saving. So first, you just write the given numbers, so 3 and 6. Then just list out its factors, 1 and 3, right? So since 3 is a prime factor, it's only going to have 1 and 3. Okay, so for 6, there's 2, 3, 1, 6. Yeah, that's it. So now let's see what's in common. 3 and 3. Okay. 1 and 1. So that's it. So we got 1 and 3 that are common. So these two are common, right? So now we want to know the greatest common factor. So we got the common factors, but we want the greatest one. And here, 3 would be the greatest one. So 3 is our answer. So this strategy is a little bit time taking, but it is pretty okay. So now for B, we just kind of do the same thing. So the factors of 3 is 1 and 3, 6 is 2, 3, 1, 6. And then 12 is going to be 1, 12, 2, 6, 3, and 4. And that's it. So now let's see what's in common. 3 here, here, and here. Then 1 here, here, and here. And that's all that's common. So again, we have 1 and 3 in common, but we want to find the greatest common factor. The answer is going to be 3 again. So that is our answer. Okay, so now these are the two types of methods that I told you guys that I will teach. And right now, the two methods are prime factorization method and the division method. So for GCF, many people call the division method the long division method. So if you hear a person say long division method, that's just gonna be the method that I am going to teach you. Okay. So first we're gonna learn prime factorization method. So let's take the example 1620. First, you just list out its prime factors. So for 60, 2 and 30. For 30, you can say 6 and 5. For 6 is 2 and 3, right? So at the end, the prime factors that make 60 is 2, 2, 3, and 5. So 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So now let's move on to 20. 20 is 2 and 10. 10 can be broken up into 2 and 5. So now the prime factors that make 20 are 2, 2, and 5. So now I want to see what's in common. So there's, let's see, 2 and this 2, right? Then, let's see, there's this 5 and this 5. And then there is finally this 2 and this 2. So 3 isn't common in both of these numbers, so we're not going to include 3. So let's look at the blue pair of 2. That's going to result in 1, 2. Now the yellow pair of 2 results in 1, 2. Then the pink pair of 5 results in 1, 5. And then that's it. So for LCM, we would include 3, but now it's not LCM, it's GCF, so we wouldn't. Now we just multiply, then we're going to get 20. So the answer for the GCF of 60 and 20 is just going to be 20. And so that is the difference between LCM and GCF prime factorization. Okay, so 20. Now 12 and 18. Same thing. Let's just list out the prime factors. 6 and 2. 6 can be broken up into 2 and 3. That's it. So let's see. These three numbers are going to be the prime factors of 12. So again, 2 times 3 is 6. 6 times 2 is 12, right? Now let's go to 18. 18 can be written as 3 and 6. 6 can be written as 2 and 3. So lastly, the numbers are going to be 3, 2, and 3. So now let's see what's in common. So there's a blue pair of 2. There's a pink pair of 3. And that's it. That's all common. So now let's look at the blue pair of 2. Results in 1, 2. Pink pair of 3 results in 1, 3. Multiply and we get 6. If we were finding the LCM of 12 and 18, we would include the leftover 3 and 2. So 3, 2. We would include those numbers, but right now we're doing the GCF, so we would not. We would only include the common numbers. And so 6 is going to be the GCF of 12 and 18. Okay, now let's move on to the division method, or again, long division. Either way. So first, let's see the biggest number out of these two numbers. 60, right? So let's just write 60. Automatically, the biggest number becomes the dividend. Divide, and then 20 becomes the divisor. We can divide by 3, and then we get 60, and then 0. Okay, so when we've reached the remainder 0, that's when we know we're done. It's going to be the divisor. So 20 in this case. So 20 is going to be our answer. So the thing is here that the divisor becomes the answer, not the quotient. So now let's move on to B. 12 and 18. First, we divide by the biggest number. So, like that. And now, 12 can fit in 18 only one time. So then 12 divide 6. Okay, so now we got 6, not 0. So now we're not going to put a decimal number and continue. The remainder becomes the divisor, while the before divisor becomes the dividend. So now 6, and then we can divide by 2. So then 12, 0, yeah. So we can multiply 2 by 6 to get 12, and then we just end up getting 0. So now we reached the 0 state, and so the divisor is going to be our answer. So 6 in this case. So here's going to be 6. So thing is, here, the remainder becomes the divisor, while the before divisor is going to become the dividend. So that is, I feel like that is really important to remember, or else you can do multiple mistakes. And like if you guys did notice, we just got the same question, right? So 20 and 60, the answer is 20. We got the same thing here. 12 and 18, 12 and 18, we got 6. Same thing. So again, this is proof that the division method and prime factorization method both do work. Now, we're going to see the difference between LCM and GCF. First, we're going to do the prime factorization method, then the division method. So first, let's do the prime factorization. Okay, 20 and 15 LCM. Okay, so first, we're just going to write the prime factors. 20, 2 times 2 times 5. 15, 3 times 5. Okay, now let's see what's in common. 5 and 5, right? And then the 2, 2, and 3 are just leftovers. So this pair of 5 is going to result in 1 5. Then we're just going to multiply the rest of the numbers. Then if we multiply, we're going to get 60. So 60 is our answer. If we are trying to find the LCM of 20 and 15. So that is prime factorization for LCM. Now GCF. 20 and 15. So first, we're gonna write the numbers, break it down to get the prime factors. So again, 2, 10, that breaks down to 2 and 5. For 15, it's just gonna break down to 3 and 5. So now the last numbers are 2, 2, 5, and 3 and 5. Now I wanna see the common. So 5 and 5, right? So those are the commons. So the answer is just gonna be 5. Because again, remember that the leftover numbers, they're just leftovers. We just leave them. So here the answer is going to be 5. If you're trying to find the GCF of these two numbers. So that would be a difference between prime factorization of GCF and LCM. Okay, so now the division method. LCM first. Again, remember, we make this huge L, put 20, 15 in it, then divide by 2. 20 is 10, 15. We can divide by 2 again. That's going to result in 5, and we can't divide 15 by 2, so we're just going to leave it. Then we can divide by 3. So then becomes 5, 5, and 1, 1. Okay, so we reached the 1 state. Now we just multiply all of these numbers. So 2 times 2 times 3 times 5. And let's just multiply, and we end up getting 60. Right, so I'm just gonna. Okay, so now let's do the division method, long division, or to find the GCF. So 20 and 15. First, we want to divide by the biggest number. So 20 and then 15. Okay, now 15 can go in 20 only once, so it's gonna be 1. So then 15, then it divides in 5. Okay, so we did not get 0. So now we're going to make the remainder again. So we're going to make the remainder the divisor and the before divisor the dividend. Then we can divide by 3 and then 15 and 0. So now, okay, so now, would this mean that 3 is our answer? Because it's a quotient, right? No. So again, the divisor is going to be the answer. So it's going to be 5. So here, instead of 5, so here, instead of 5, we got 0, say. Then 15 would be the answer. But no, we got 5, so it's not. And so the answer is 5 here. So again, proof, prime factorization and the division method do work. And I hope this video explains the difference between LCM and GCF, the difference between the methods. And so that is it for today's video. So before we all go off, don't forget to subscribe, like, and share.